It's elementary charges, what are we singing about? You know you liked that. Yeah, you know you did. I don't know if you did, but let's talk about some elementary charges here and Captain Quark. So what we're talking about here with elementary charges is the idea that if we have a charge of a single electron or a single charge, because it could be either electron or proton, the elementary charge is the smallest fundamental charge that is allowed to exist. So the elementary charge, which we will designate as just the letter E, okay? Because this letter E could be an electron, it could be negative, or it could be a proton. It could be positive, okay? The E just represents an elementary charge. And this elementary charge, like I said, it is the smallest fundamental charge. Oops, quotes too early. It's the smallest fundamental charge. Okay. Now, this smallest fundamental charge we have here is, by what we have found through, when I say we, I mean science in general, has found, it's approximately 1.6 times 10 to the minus 19 coulombs. Okay. This is important. When we get into nuclear, we'll be a little bit more precise than just 1.6, but 1.6 will work for what we're doing here, back of the envelope stuff. Okay. This is the charge of an electron. It is also the charge of a single proton. This is the elementary charge. Okay. Now, as much as this elementary charge exists, we also have to start thinking to ourselves, how do we get this charge? Why is this the smallest fundamental thing that exists? Now, what we're about to talk about, Captain Quark, goes a little bit beyond the AP Physics 2, so if you're just cared about AP Physics 2, stop here, see you later. But if you want to learn some more stuff, we can also talk about what are known as quarks. And you may have heard of these. They're quarks. And when we talk about quarks, what we're talking about even smaller building blocks. So if in your prior classes, maybe chemistry, they were like electrons, protons, and neutrons, which have no charge. These are the smallest, particles, and they're the building blocks of everything. That's kind of a lie. It's kind of the truth. It's also kind of the lie. Because some of these particles can actually go smaller. They can be made out of quarks when they are made out of quarks. And there are 6 types of quarks. There are up quarks, which we designate with an up arrow. There are down quarks, which we designate with a down arrow. There are top quarks, T. There are bottom quarks, which are B's. And then there's 2 quarks, which have really weird names. They have strange names. One is literally, it's called a strange. And the other one is called charm. Okay? These are the 6 quarks. 1, 2, 3, 4, 5, 6. We are going to ignore strange, charm, top, and bottom. Who cares? What we're going to look at is up and down quarks here. When we look at up and down quarks, up quarks actually have a charge of positive 2/3 of the fundamental charge. And down quarks equal negative 1/3 of the fundamental charge. So here's a little challenge for you if you're watching this. If you wanted to make a proton, which has exactly 1 fundamental charge, how could you combine the up and down quarks to get that? If you wanted to create a neutron, which has no charge, how could you combine these 2 to get that? And if you wanted to create an electron, what would you do in order to get that? Okay, we know the electron has a -1 charge. So pause the video, think about that for a few seconds, and then unpause and we'll come back. Here's a funny face I'll make while you're paused. Okay, that was that. So if we want to make a proton, we can actually go up, up, down. If we go up, up, down, we're going to get 2/3 plus 2/3, so that's 4/3, minus 1/3, which is positive 3/3, which is 1 elementary charge. So that's good. If we wanted a neutral atom or particle, we can say the neutron is going to be an up, down, down. 2/3 minus 1/3 minus 1/3 gives us nothing. And if you think, oh, we'll just follow this pattern, the electron will just be down, 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 you'd be wrong. The proton and the neutron, that is exactly how they are made. They're made of quarks. The electron, it is not made of quarks. The electron is in and of itself a fundamental particle. It is as small as it can be. The electron is made up of itself. There is nothing smaller than the electron's existence. But for whatever reason, protons and neutrons are made up of quarks, not the electron. It has to do with the fact that in your protons and neutrons, because they're made up of quarks, quarks have a gluon property which allows them to bind together on the atom in the nucleus. If electrons had this property, they would dive bomb into the nucleus and you wouldn't have an outer orbital shell there. So that's kind of what's going on there. If you're more interested in that, you can check out page 904 of our G and Coley book. It's got some stuff on quarks in there, or just start deep diving the web and have fun with that. Okay? We kind of discovered a lot of this stuff in terms of quarks through particle collisions on colliders. But yeah, that's a different topic for much, much future. But that's pretty much a little background on fundamental charges. Really just understand that you need to be integer amounts of this fundamental charge. It's 1.6 times 10 to the minus 19th. So you could be 1.6, 3.2, 4.8. Those are all good values, but you could never have 2.4 times 10 to the minus 19 charge because that's not an integer amount of the fundamental. Okay? Those are the smallest amounts we can have, and we can only have integer amounts of them for 1 electron, 2 electron, 3 electron, 4. You get the idea. Okay? So next video, we're going to take a look at some examples on how to actually look at some electrostatics and incorporating Coulomb's law. But for now, adios. Have a good one.